Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. This is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, how's it going?
Hi Michael, all good. How are you? So what's the topic today?
The topic is how bad my internet connection is. The topic is data types, but I feel like I must have just frozen just now.
What kind of data types?
Yes, we're going to try and keep this to half an hour, so we're going to very much have to do a 101 intro to data types, but I think you've got some interesting things you want to go into first, right?
Yeah, well, so data types is a huge topic, and we probably should just try to provide an overview and some entry points as usual, because for podcast it's impossible. If you want to squeeze it into 30 minutes, it's impossible to cover all the topics. Postgres has huge number of data types supported, and extensions bring even more and more data types, obviously.
Yeah, I've heard it described as one of Postgres' main strengths, one of the biggest reasons to choose Postgres, which I completely agree with. Did you want to talk about system types to begin with?
Yeah. So before we go like really wide, we should discuss, this is my idea, it was my idea. Yeah. Let's discuss data types each Postgres always has, because they are internal. And I encourage touch some data types even if you just start working with Postgres. Recent episode with tips for beginners and in a related article I posted. It mentioned CTID data type, which is quite useful to understand how MVCC, multi-version concurrency control, works in Postgres, and to start understanding versions of rows, and like to feel how vacuum works basically, and so on. And this is just a hidden column in any table, and it provides you two numbers. So it's like composite type. It provides you two numbers, which tell you location of a tuple. So page number starting from, I guess, 1, or I always forget, 1 or 0. So page number and offset inside the page. And the interesting trick, as I usually say, you can extract one of parts if you just convert it to point first and then address first or second part of this value. It's just a trick which you can use to do some, some statistics to learn how your data is currently organized. And of course, if you perform some updates, insert, deletes, or to vacuum or manual vacuum processes the table, of course, physical layout changes and some rows can migrate to different pages. And this is one of the system types which is worth knowing and using from time to time.
Yeah, I really liked your tips on using this to get an understanding for how things work at the disk level. So understanding that tuples are row versions and that they can move, and that they get a new CTID when they've moved. Like if they've been updated, even if it's like a no-op type update, they can move. That was really good. The first time I actually came across this was I did a whole glossary for explain and all the different operations and fields you could see in explain. And I came across a TID scan, and I was like, what is this? And it was so interesting to read up on it. It's generally only used, it's like an internal thing. You can use it, but it's generally a bad idea because tuples can move. So that was my first experience with it.
Right. Also, there are a few more data types you probably want to at least know they exist, and I'm sure at some point they will be useful for any, even like backend engineer, not just for DBAs. Of course, all of these things are implementation details, and it's like kind of internals, but it's very useful to know about them. For example, LSN, there is a data type called PG LSN, and it's a kind of our moment in time. So it always grows, and interesting thing to remember: if you have two LSNs, you can subtract one from each another, and you will have a delta measured in bytes. So it's really easy. Just use operator minus, and that's it. You will have. Of course, there is some function pglsn diff or something, but anyway, like delta of LSNs is it's log sequence number. It's position in wall, and it's constantly progressing. Of course, there is another value XID, transaction ID. You can also play with it. It's like regular integer, so you can work with it as well. But LSN is very interesting, so you can understand how much data you produce in terms of wall data. All writes go to wall, obviously. Also, vacuum can write to wall, and shift LSN as well. So and maybe final thing from me is a pair of useful data types, also internals, OID and reg class. So each database object has OID. It's like object ID inside database, and it's internal. There are some OIDs which are hard-coded in Postgres code. For example, when new system table, system view, or new data type in core is added, it has assigned OID, which is just written in source code. And even there is a function, there is a script, in helper script, which help Postgres developers, Postgres hackers, to find unused OIDs that can be used. So there are some gaps sometimes. So OID, for example, if you create a table, it immediately has OID assigned, and you can select it from system view called PG class. So you select PG class where real name equals your table name, and you can find OID. And also there is a type called reg class, which corresponds to records in PG class, and all tables and indexes are there. Also views, materialized views, they all are there. And interesting trick is that you can take OID and just convert it to regular table name or index name, just saying : reg class. This is interesting. This is the shortest way to get table name from OID. And if in vice versa, of course, so you can convert it back to OID. So it's useful sometimes to deal with some catalogs and to find, for example, if you have very wide rows for some table, you know there is toast. We had episode about toast. When you have toast, you sometimes need to convert table name to toast table has OID of main table inside its table name. So you need to play with it, and understanding that it's so easy to convert to OID and back to relation name. Relation name. So relation, it's kind of overused term, but almost anything is a relation. I mean, table is a relation, even index is a relation, and they all go to PG class. So you can convert back and forth just remembering type names. And the most difficult is to remember reg class. I tend to forget it, but I use it quite a lot as well.
I came across it recently when I was hosting the PGSQL Friday event, and somebody, I think it was Diane Fay, used it in their query for pgstat statements as a really neat way of casting. So actually casting is the important word there, isn't it? The : you mentioned is used to cast from one data type to another. So it's really cool, really powerful.
Yeah, and it's Postgresism, because standard ways say cast something as something. I never use it because it's too bloated. It's better to just write : because I definitely know I'm not going to migrate from Postgres to anywhere.
Nice. In the interest of time, should we move on?
Yeah, let's talk about probably like basic atomic data types like numbers and texts and dates and times and so on. Where to start, numbers or text?
I think text, because I thought this was quite like a nailed. When I first started learning about Postgres, the advice I read felt like really sensible, and I got on board with it. And then the more I learned, the more I realized it's like a little bit more complex. So I feel like this might be one of the more interesting ones. So the reason that I think it's interesting is, unlike a lot of relational databases, Postgres has a text type that, and a lot of the other databases rely on character. Mm-hmm. Yeah, exactly. And character limits are really common in a lot of when people are using Oracle, SQL Server, and others. And I think there's a few guides out there, and a few, even the wiki. In fact, I was going to mention this later, but the Don't Do This page on the wiki is brilliant for data types. So I'll link that up. But one of their advice is generally to use text, and they go into good reasons as to when it may or may not make sense. But yeah, how do you feel about that?
Is it the same wiki page which says don't use money?
Yep. And don't use timestamp TZ. Don't use timestamp. Use timestamp TZ. Yeah.
Don't use money sounds funny, actually. Inside Postgres I tend to follow this advice, but outside I prefer not to. So it sounds like communism, But as for text, first of all, Postgres supports varchar char as well, like a standard.
Yep.
So standard data type supported, but with some addition, varchar can be used without limits as well. You can say varchar, and it will behave similar to text. And on Stack Overflow, there is a question where I think Peter Eisentraut commented that there is very, very small difference in terms of performance because there is some additional code. Well, I have mixed opinion here, because first of all, of course, it's good to care about performance, but it's also good to care about data, the quality of data. And when we talk about quality of data, we need constraints. And varchar offers such constraint. And actually, if you define varchar 100 and then next day you decide, I need 200 characters, it's just an alter, and it will be quick. It will not...
No locks, even if you've got a lot of data in there.
From 100 to 200, it's obvious we don't need to scan table, right?
Well, in theory, but not always things that are in theory possible are true.
I recently checked. I was surprised it's not scanning table. Well, maybe I'm wrong, actually. But it's easy to test. You generate a huge table, you start observing logs, measure time, and so on, and you see if it scans table or not. I suspect in one way it won't. It won't.
I suspect we could spend the rest of this episode on this specific topic. I remember a really good blog post on this.
Maybe it's outdated.
Well, Brander did a really good in-depth blog post on this. Pardon me?
How many years ago?
Only recently.
Depends on version, probably. I don't know, but I recently I was explaining someone that it's so, as you say, and I wanted to, as usual, when I say something, I first of all I need to double check myself, so I do experiment, always experiment. So just check it and see, and I needed also to demonstrate with real experiments. So I made experiment, and I was surprised that it didn't perform. It was very fast in this way, like from 100 to 200, increasing this limit. So again, it's better not to memorize these things, but know how to check these things. It's always good to check, and it's always also good to have some testing system which will not let you to deploy bad change, which will block table for long.
True.
Right. So we discussed that about database experiments, testing, and so on. Also, so it's that area. But to use text. But my question is, how are you going to control the length? Many people tend to control it on application side, and many years ago I was very. I was criticizing them a lot because I was saying, look, only database can control constraints reliably, because application, soon you can have several applications and you need to copy paste this logic in different languages probably, right? It's not good. A database can control this and so on. But they had reasons, for example, painful schema changes. Yeah. Because I get it. And for example, if you tell me you are going to use enum, even with recent support, I think in Postgres 13 or something, it was added, you can alter it saying I want one more value in enum. I will say, okay, what if tomorrow you will decide to remove one value and you know your table doesn't have it anymore and it's terrible. So instead of enum, probably you just, it's better to use just check constraints and know how to cook them. You do it in two phases. First, you define check constraint with not valid flag. After each, some people think it doesn't work if you say not valid, but it works for new values. So all inserts and updates will be checked for this check constraint, even if it's marked as not valid. But not valid means we skip checking existing data, and then you in different transaction you say alter table, alter constraint, validate constraint, and in this case you don't block anyone, and it's so good. And in this case you can create another constraint with this approach and drop old constraint, and this is how you migrate to different set of values to be checked. So I prefer this recipe instead of using enum. And similar here, well, I honestly also use text in many cases, but it's not good when you want to store email and then you forget in your application, you forget to check it, and then someone inserts 1 gigabyte of data, because Postgres supports up to 1 gigabyte of inside one value. It's huge, right?
So a question, can you use check constraint for the length then? Why is it different?
Exactly. Yeah, you can, and altering them probably is easier because like it can be fully automated. You can you just define in two phases. You define new constraint, drop old one. That's it.
I've never seen that advice, but anyway, maybe there's good reason that it doesn't. But yeah,
good
seems
about it
to me.
Good about this approach is that it can be you can work with any data type, even with JSON. You can take JSON and say I have check constraint. This JSON always must have this key. Well, you can build even JSON schema around it. And I think Supabase guys did something like they have extension probably for kind of JSON schema to put some constraints. You know, sometimes you want, again, for data quality, you want, if you work with JSON, you still want to have it like semi-structured. You want to have some keys existing or some values inside keys or some arrays, objects, I mean, and so on. And in this case, you can define some check constraints that will prohibit inserting data you don't want to be inserted. And I mean, this recipe can work with any data type. This is the good side of this recipe.
Yeah.
And we know how
by the
to
way, I think
deploy without blocking.
I think I agree with you on the enums front. I did once see a really good, really entertaining talk by Boris Meichas that I liked, trying to defend the enums, trying to say all the positive things about them. But I think overall I agree with you.
Yes.
Yeah, exactly. Well, it was a valiant effort, I think. But do you want to move on to numeric types?
Numeric types. Okay, yeah, sure. One of recent tips I had, again, in beginners topic as well, we had it, don't use integer for primary keys.
Yeah.
And just don't. And what else? Like numeric, if you talk about integers, there are like small int, normal int, 4 bytes.
I think
big int.
Floats are an interesting discussion, and I think there's some subtleties here. Like,
I wanted just to mention that some people think big int and small int. I just saw it recently. It's not standard. Well, it's standard. Small int, big int, all that relational databases which want to follow SQL standard implement them. So big int is the choice, but not always. I mean, if you know about storage, we will probably touch the storage topic separately, but sometimes, of course, you want fewer bytes to be spent, right?
Yeah, I think for keys it's different to generally for columns. So I think for keys it makes a lot of sense, and a lot of the advice that's out there, a lot of the good talks that have been given are not necessarily quite old, but they're pre-version 10 of Postgres. So a lot of them mention serial and big serial, but now we have identity, so that problem goes away.
I still cannot develop a habit to use it. I still use big serial primary key.
The only downside of the identity type is it's so long. Like to type it out is like such verbose syntax. But yeah, I'm trying to get in the habit of using it because it comes
it's
with
standard,
fewer
right?
pain.
It's
standard, but it also has few. Like serials have some like weird complexities, especially especially if you end up having to migrate. As we discussed in the downtime.
A column has owner as a table has an owner of sequence.
Yeah.
Ownership. This is kind of So about float, what do you want to hear? I recently learned from Peter Gagan on Twitter.
Yeah.
Who mentioned that OreoliDB published very good benchmark showing how how it's good to live without vacuum, and they chose benchmark which relied on float 8 columns, like I think 4 columns, and created B-tree. And Peter Gagan mentioned that unfortunately B-tree optimizations he worked on in Postgres 13 and 14, deduplication, right? These optimizations don't work with float 8.
Which is a big deal, right? Because they were looking at the impact on bloat, especially.
Float at all? Well, maybe some people won't.
Well, the general advice in the wiki is don't use it. Use numeric with precision.
It's like don't use money, don't use float 8. Similar, right? Because
precision. And they give. The thing I really like about that wiki is they do go into when should you, like what are the exceptions. I think it's a very, very smart way of doing it. But in general, if you've got any doubt, just don't, unless you know exactly what you're doing. The optimizations by Peter reminded me also that recently, I think it was Postgres 15, maybe 14, added a bunch of optimizations around sorting specific data types. Mm-hmm, and I think the more common or the more standard a data type, the more popular a data type you choose, the more likely it is to benefit from some of these optimizations, whether that's in indexing or sorting or something. I think it's
or vice versa, because for example, if you store your JSON, if you store some vectors inside text column and expect good performance for some algorithms for arbitrary nearest neighbors search, ANN, right? In this case, you probably will find out that there are extensions which provide better functionality and performance.
Yeah. Before we move, I think we should talk about advanced types in a moment. Just before we do you have anything you wanted to add on? Like you did a whole episode on UUIDs, so I think we can probably skip those.
Yeah, let's skip it.
Anything on Booleans or dates and times?
Well, Boolean is not 1 bit; it's 1 byte.
Yeah, and dates and times the general
unexpectedly bigger than just 1 bit. So, say it again.
Dates and times, the general advice is timestamp
TZ and pay attention to ranges. Learn ranges. Ranges are great. Right?
Good shout.
Ranges are great. They have indexes also. So if you have beginning and ending points in time for your data, consider ranges. Yeah. They will guarantee they will also take care of data quality. You will never have beginning which is in future compared to ending point. So,
really awesome feature.
Yeah, and of course timestamp TZ, timestamp with time zone is better, and just prefer using it. That's it. So I also I think I recently was productive in terms of tips, and one of the tip was to block authors and consultants who explain some Postgres stuff to other people. And I asked, and it was it resonated. I saw many good feedback, and I mean people liked this idea. Let's stop using integer 4 for primary keys. Let's always use integer 8 and develop help people develop a habit to use integer 8. And same for timestamp. Let's stop using timestamp. Let's use timestamp TZ. This is good things for those who write blog posts or develop some, I don't know, educational courses and so on.
I agree, and I would add using identity over serial and big serial.
This is probably yes. Well, and in this case, you need to advise use cast instead of colon and so on and so on. Like, it depends. If you like, I don't care. I prefer Postgresism because they are usually more compact and it's just more convenient for me. So I'm going to continue using sequences and big serial. But if you, for example, develop a course for students who you don't know, like many of them will probably go to and use Oracle, for example, but you use Postgres when you educate. In this case, you need probably to stick with SQL standard language syntax, right? In this case, yes.
Well, I was just teasing because I know you said you still use serial.
Yeah, well, today I see your face. I knew you're teasing, but still worth explaining. Let's move on, probably.
Yeah, all right. Advanced types, arrays, JSON.
First of all, we are going to break first normal form. The first normal form, 1NF or NF1. I think canonical naming is 1NF, right?
I actually don't know. Is it like probably one of them's French or something? That's how these acronyms normally get put the wrong way around.
The first normal form says you should not put something which can be split to things inside a value in your tables. But text can be split to things, and we know in many languages text. And for example, in C, it's considered as array as well. Like you can work with it with array. So there is a first letter, second letter with like index 0, index 1, and so on. And so it's interesting thing. But anyway, Postgres is very advanced. We easily can put in queries. We can even collapse whole table, whole relation in one value and then unpack it, manipulating. But it's a different story. As for complex data types, first of all, arrays. They can be of many underlying that data types, for example, integer 8 array or integer 4 array or text array and so on. Mm-hmm. So it's great, but of course you cannot mix. So you cannot have both int and text values inside the same array. And things to remember: the indexing starts with 1, not 0. This is unexpected to many, and leads to interesting mistakes sometimes. Arrays are awesome. I just can say, like, I use them a lot. Array _agg function, which helps me when I group something. I can collapse group many things inside one value, and then I also use parentheses. And I can use, like I say, I need only first 5 elements to see. For example, if you select from pgset activity and you want some queries, I use usually left function to cut them. Left query, comma, 100, for example. And then I use array _agg to aggregate them, and then I add additional parentheses, and then access indexes from 1 to 5, and you see only first 5 elements. Quite convenient. In one single input for one row, you see 5. You can also order by inside array agg.
Oh wow,
that's unexpected to many. Inside the aggregation functions, maybe count doesn't count here. Sorry,
I feel like you told me that before, but I've still haven't stored it somewhere.
Yeah. So when you aggregate, for example, JSON, agg, text, and array agg, so you can aggregate. And in this case, you can say, I want specific order for when I aggregate. And this order can be different compared to order by clause in your statement. So it's kind of interesting trick. But what else? Like we have arrays, it's only the beginning of the topic, right? It's a huge topic. I mean, complex data types.
I feel like we should skip JSON because we did a whole episode on it, and we can point at that. And
just don't follow advice. Those who say prefer always JSON-B over JSON, they probably not completely. It's not probably very good advice. In some cases, JSON is much better in terms of performance. So just check. Use both, I would say.
Yeah, Yeah, or read about both and see which
Right.
suits your. I think I've seen way more use cases. I've seen way more people using JSON-B than I have JSON. I think for good reasons. Like,
Also,
yeah,
arrays
we've
and-
discussed it at length, haven't we?
Arrays and JSON is a way to escape from entity attribute value approach, which is terrible when you have a lot of data. These joins will be terrible, and you can have like kind of it will not be foreign key, but you can put many IDs inside one row in this array value, and then try to join using a nest function. But it's kind of interesting, and probably you will have better performance. But again, JSON and JSONB. Let's consider HStore and XML as kind of semi-deprecated
Yeah.
types in our
Yeah.
case. I would try to avoid them. Despite the fact I participated in development of XML and type and functions many years ago, these days I would probably, unless needed, I would try to avoid them. And HStore is very old. It has good features, but most of the time you will probably be good with JSON, and it's what other parts of your architecture probably understand. And what else? We have also many others. For example, full text search, TS vector and TS query. They also they consist of many things. It's TS vector, based on the name, you understand, like it's many words combined to one vector value, and you can create a gene index and have good performance. New thing, PG vector, for very high dimensional vectors, like up to 2000, I think they say, and for not strict neighbor search, but arbitrary neighbor search for this LLM ChatGPT area of engineering, which is currently very hot. In this case, PG vector. But by the way, PG vector is not the best in terms of it implements not the best algorithms. So there is now competition, and I know Neon developed something, PG embedding, right? But PG embedding is quite new, and it doesn't. It's like it builds index in memory. I know they work on making it persistent, this index. So, I mean, if you restart Postgres, you need to build an index again. What? So it's very new. I wouldn't say it's production ready yet, but it's very interesting because it implements a different algorithm, which probably is considered one of the best right now.
I think we're going to need to do a whole episode on PG.
Yes, let's do it. About vectors.
Another one we haven't done an episode on that it feels rude not to mention in this space is PostGIS in terms of data.
This is exactly, and a lot of stuff there, a lot, of course. So many data types, many functions, and it's a whole world.
Yeah, incredibly impressive and hugely popular. We've mentioned performance a few times. Is there anything you wanted to make sure we talked about? I feel like that's where some of the choices between these gets interesting. Is there anything that people should definitely be aware of?
Well, I don't think we have a lot of time right now, but let's just probably mention a few tips. First of all, documentation.
Yeah.
Wiki is also good, and many articles and blog posts are good. Probably we will attach a few articles which are helpful in terms of learning about various data types, but also a data storage tip related to alignment padding. Due to alignment padding, Postgres always need to fill gaps. So if you put 1 byte and then you put 8 bytes, Postgres will need to add 7 zeros between them. So there is an approach. You basically need to either in ascending or descending order arrange. So starting from 1, 1, 1, 2, 2, 2, 4, 4, 4, and so on bytes, so they pack. Or vice versa, you have 16, 16, for example, timestamps, then 8, 8, 8, and there are articles about it. And also, but there are also varlina data types like text, varchar, TS vector, vector from PG vector. I'm sure it's varlina because it allows very huge, huge values up to 1 gigabyte probably as well, involving toast. These values you should move to the end of the table. In this case, you will have as few zeros, these gaps, as possible. And it's called column Tetris, basically. Someone on Stack Overflow named it, maybe earlier, I don't know. There are a few articles about it. And sometimes you can save a lot of space, but don't overestimate it. I saw people immediately love this topic and try to optimize, and in many cases it looks like premature optimization because, okay, you save like 3% of storage, but you spent a lot of engineering time.
I read a post by Braintree that had huge tables that were very badly optimized, and I think they saved about 20% from 10 to 20% from memory.
That's a great example, but it's rare.
Rare, and they're Braintree. They're huge. So this might have even been like post the PayPal acquisition. So it might have been PayPal.
My old ad hoc tool called Postgres DBA has a report which is very interesting recursive CTE I wrote one day. I'm still not 100% sure it will work in all cases, but so far it works quite good, and it can it can tell you about potential optimization in each table. So you can use it and try to understand if it's worth spending some time to rearrange columns. For some people, it's unexpected that Postgres doesn't do it itself. It's interesting, but it's so. Postgres will store columns as you define in create table definition. So.
And something I only learned today when I was looking it up, I wondered if PG Repack supported changing the order, but it doesn't. Based on implementation details, it can't really.
Yeah.
So it's very interesting, but
there is potential.
You're going to have to roll this yourself, basically, if you want to do this. So
there is potential to have it, but it's not supported yet, unfortunately. Yeah, you need to rebuild the table and deal with it. It's a huge task. If you want to do it without downtime, it's a huge task. But as you remember, we mentioned don't use int4 primary key, because I saw it very often. Int4 primary key, which is doomed to have a wall being bumped into when you reach 2 billion rows, 2.1 billion rows roughly, right? Half of integer 4 space. And then second column is the timestamp TZ, which is 16 bytes. So we definitely know we lost 4 bytes because they're just alignment padding, and we have zeros there. If we used int8 from very beginning, we wouldn't have this problem with capacity, and we also we would use the same amount of storage, which is very unexpected, but it's so.
But I think the argument stands. I think the argument stands to use int8, even if you were having to pay double the storage. I think there's so much benefit, because if you're not, let's say you don't hit 2 billion rows, you haven't got that much data to worry. You haven't got that much storage footprint anyway. But if you're worried about the storage footprint, you're probably thinking you're going to have more than 2 billion rows. So that would be my argument.
Yeah. Okay. Maybe one more advice on your choice, and that's it.
Oh.
What do you think we should?
Well, I see a common argument. It's not just for data types, but people that choose to do things in a standard way, or a way that will let them convert between databases over you choosing the power of the current database they're using, thinking, what if we need to migrate one day? And I think it's an easy trap to fall into. It sounds smart, but I've not, like any of us that have been around for a while, you don't move databases that often. Like, it really, existing projects have a lot of momentum, and it costs a lot to migrate. There are arguments for doing it. We see some from some very expensive vendors coming to Postgres, but it's rare, and it's basically so much work that I think you're really hurting yourself by missing out on the power, especially of Postgres, especially when we're talking about so many of these things that have so many features, so many functions, so much power, that it feels like such a waste that you'd be missing out on that. It's
like choosing C++ but staying with C only syntax, like very basic types and so on, and not using power of C++, or something like you chose Java but think, oh, maybe one day we will migrate to, I don't know, like to something else, and you restrict yourself using only 5% of functionality. It's nonsense.
Yeah, I think so, but I see smart people falling into that trap. So that's my advice would be, try to avoid that, or don't
consider database as something like as gloves. It's a heart, not gloves. it's the heart of your system. You are gonna
Heart.
you're
Oh, yeah.
heart. Yeah, you are not going to replace heart easily. So database is in the center of everything.
Yeah. Heart transplants are possible, but they're rare.
Well,
and
yes.
They can go badly wrong.
It's not gloves. You can just
Yeah,
change
yeah.
them
I
every
like
day.
it.
Yeah. Okay, good. Thank you so much.
Brilliant. Take care, everyone. Cheers, Nikolai. Bye.
Oh, we should remind those who listened until this point, please help us grow with likes, with comments, with feedback. It's both helpful for us to understand we are being heard, and also it's helpful, for example, on YouTube. If you like, of course, it due to algorithms, it helps our channel grow and make audience bigger and make this project more interesting, basically. So
True. And requests as well. Feel free to drop requests in
Yeah.
the comments on YouTube.
we need more
or in our-
requests.
Yeah.
More requests,
Yeah.
please. Thank you.
Thanks, everyone.